Right, so here we are in week 2, and this week is all about rigid body simulations, rigid body dynamics as they're known, RBD. So let's create a project. So project name will be module 2. I said we're in week 2, and we're in module 2, week 1. Week 1, let's have a little dash there. Okay. As per usual, you can save it wherever you want. So we'll basically just build up in complexity in this first week, just looking at the bare bones of a rigid body bullet simulation, and just kind of start off super simple, look at a little bit of fracturing and some constraints towards the end as well. So let's just start with a geometry node here, and we'll call this RBD intro. Okay, dive inside. Let's get a box. We'll start with just the easiest way to make some kind of simulation. We'll start with a box there. Press P to get my parameters and just raise it up. Maybe rotate it randomly. Don't worry about copying parameters. And then press Tab and look for RBD bullet solver. Okay, visualize that. And we've got 2 nodes, and we've got a simulation. I mean, it's not super interesting, it's just falling down. Make it a bit more interesting if we go into ground here, give it a ground plane, and it just drops. So, that is a bullet simulation. Super simple, but it is what it is. 2 nodes, look at that, so easy. So, the bullet solver, RBD bullet solver, so being able to do all this in SOPs is a recent addition, and it kind of does a lot of things under the hood here. So as you can see by this padlock, it's it's got a lot of stuff going on the inside. So, and they expose all of this to you. So let's look at how, because typically I tend to use these, but it could be that you need to have access to the DOP network to be able to build this in DOPs as well. It's important to know how to do that as well. So we'll look at that. So let's have a DOP network. Okay, plug that in. So we don't have anything in here yet. So let's find, we need the rigid body solver. Got a few other solvers. There's just bullet solver, and then you've got the RBD solver, I think, there as well, but this one kind of encompasses both. I always use rigid body solver for RBD simulations, and it's using bullets. You have RBD as well and this fracture thing, but I never use them, just use it for bullets. And then RBD packed object. So that needs to go in the first port, and that gives us a clue. We're not seeing anything yet. If we go to first context geometry, we are seeing that. We've got our box there. So we've got an error there. If we take a look, we can see geometry does not contain any primitive types supported by the solver. So what that means is it's looking for packed objects, but we don't have a packed object. Okay, so this is doing that internally, is packing our box. So what does that mean? If we look at our box here, you can see, we have access to all the primitives. It has 8 points, primitives, and so forth. And now if I drop, it's saying we need packed objects. So if I just type pack, put that there, take a look, you can see visually it's kind of looking different. And when I go to select it, that looks different. It's only one box. And then if I look at the information, now I've just got 1 point, 1 primitive, one vertex, and we got this new thing, packed geo, 1 packed geometry. So it's kind of an efficient way of dealing with geometry. With this, all of those points and primitives and the location of all them is packed away, and we don't have access to them until we unpack. Okay, and then we have the same as what we had before. So this is, bullet requires packed geometry. It has to be packed. to work. Okay, so this will, it's simulating now, but it's not doing anything because we don't have any forces. And once you do pack something, if we go into the geometry spreadsheet and go into, if I can remember, primitives and then intrinsics, you can see we've got a whole bunch of other attributes here which are specific to packed geometry. So packed full transform, you can see we've got a load of values here related to the transform of where our box is. Okay, and you can use these for to manipulate your geometry before going into the simulation or within the simulation as well, but typically you don't really need to do that, to be honest. So we could add some gravity in here, same gravity that you use in any simulation, just gravity, put it there, so now it will fall. And let's give it a ground plane and merge that in. So hopefully, if you are just starting out with Houdini, we've done a few different simulations already. You're starting to see a pattern with these simulations that we always have object, so that whether that's RBD object or a vellum object, a pop object, and then you have a solver. 99 times out of 10, you have gravity, a ground plane, and they're merged together this way around, and that goes into your output. It's just kind of the same pattern, and then you just add on your other bits and bobs. Often you have a source, which you can do with bullets as well, but we don't need to. So there we go. We got the same thing now. It should look identical, I think. If we template that, we've got the same, more or less the same thing happening. We've probably got different physical properties like bounce and stuff like that. Okay, so there's your first bullet simulation. How exciting. So obviously next we'll look at making this more interesting, more complex.